I'm very excited to welcome our first speaker. Our first speaker of this track, Erin Grasmick, Senior DevOps Engineer at Parity Technologies. She will share her experience and learnings on maintaining blockchain nodes like Rococo testnet and production-ready parachains like Westmint. She will basically tell us why rebooting the server isn't enough just to fix the errors. Welcome, Erin. I'll let you take it from here.
Okay, thanks, Ricardo. I'm happy to be here. I'm Erin, as Ricardo said, a senior DevOps engineer at Parity Technologies. And I'm going to be talking about breaking blockchains. And this is something that I've run into a few times in my time at Parity. Maybe you have as well. So this is just going to be kind of an overview of certain ways that you can break the chain and hopefully how to fix it. Okay, so how can we break a blockchain? They're surprisingly resilient. Substrate is a very resilient technology, but things do happen sometimes. These are some of the breakage types that I most commonly see. This is definitely not a comprehensive list. There's many other ways to do this, but operationally wise, this is the most common stuff that I see. They kind of break down into like a few different types of breakage. The first is block production, when the chain stops producing blocks as expected at all. So the chain doesn't proceed. Finality breakage, when the chain continues producing blocks but is no longer finalizing. And this can continue for a very long time. And then runtime upgrades, if a bad runtime upgrade is pushed on chain, then it can cause things to break. Things that can cause block production to halt, issues with the node's key stores, issues with the chain spec you're distributing, validator nodes being offline, or collator nodes being offline, peering failures, no incoming connections allowed, that sort of thing. For finality, if you have too many validators for a chain offline at once, generally this kind of stuff, like with the offline offenses and having too many validators offline, this is much more likely to happen on things like testnets, where you might be spinning up a bunch of nodes all at once to test something like internally, or for a public testnet, if you operate the majority of nodes in a network. Obviously, like a lot of these problems go away with decentralization. So like the more decentralized your network is, the less likely a single operational failure or several operational failures can break something in a terrible way. And then, there can be just like, issues with code. Things can kind of break in a general way. So we'll go into these in a little bit more depth, and how we can fix these problems. So let's address Keystore issues first. Make sure there's the correct number of keys in Keystore. This sounds extremely obvious, but this is kind of meant to be like a checklist, because when something goes wrong, it's not necessarily easy to sit down and think rationally when a chain is stopped. So it's good to start at the top and check everything just in case. The keys are in the correct key store on the file system in the case of running a collator node. This is something that can happen if you accidentally run something like rotate keys RPC on the wrong RPC endpoint for the node, since collator nodes expose two RPC endpoints. If you accidentally run rotate keys on the relay part of the collator, then it's not going to populate the key store. Make sure your keys match those which are set on chain or in the chain spec. Another kind of obvious one, but especially if you're using pre-injected keys or derived keys or whatever your methodology is, they definitely should match the keys the chain is expecting. Otherwise, the validation will not work. Make sure the keys are in the correct format if they've been manually injected. SR25519 versus ED25519. This is, again, maybe obvious. If you're using rotate keys, you don't have to worry about this. But just something to think about. Make sure the substrate process can read the Keystore. Make sure that the file system permissions are correct. For example, if you're not running your substrate process as root, which you shouldn't be because that's good security practice, make sure that that process does have access and ownership over the Keystore. And likewise, make sure it can write to the Keystore because it needs to do so if you're rotating or injecting keys. For offline offenses, make sure your nodes are running with validator or collator. Again, really simple, but I think a lot of this stuff has like a lot of training operationally. Like if your team hires new DevOps engineers or something and they're not familiar with Substrate or Polkadot, a lot of these little things can really hang up people for a while. Make sure the nodes are well connected and they have peers. If you're running an instance of Substrate telemetry, which I would recommend that you do, it's very useful for this. You can just see at a glance how many peers all of your nodes have. They should all probably have at least 7 to be well connected. Check the chain at the end of the session in Polkadot.js for some offline events, and note the stash addresses which are offline. And then you can go check on those nodes which are corresponding to the stash addresses to make sure that they're doing okay. Make sure that your nodes are on the correct chain or genesis. Again, Substrate telemetry is useful for this because they introduced a feature recently which divides chains by genesis. So if a chain is on a different genesis but has the same name, it will show you this, which is extremely helpful. Make sure your nodes are fully synced. If your node isn't fully synced, it cannot help produce blocks, and always keep backups of the database so you can quickly bootstrap new nodes if something fails. If you have a catastrophic data center failure, your data center burns down, whatever, make sure that you have enough mitigations in place so you can quickly bring nodes back up. So Finality Stalls. Make sure that all expected validators are online because they need to submit their grandpa votes. If the chain is expecting a certain threshold of grandpa votes to be received to ensure finality progresses. If it doesn't have these votes and it's still expecting them, it won't progress. So it's really good to get those validators back online as soon as you can. Again, make sure the nodes are on the correct chain and genesis state. Again, make sure the nodes are fully synced. Wait a couple sessions and ensure there's no offline events. If all of your nodes are online, they should be getting their grandpa votes in. And if you don't see any finality progressing after a couple of sessions, use grandpa.nodestalled. And this will kickstart finality if the validator set has been changed in the meantime, because otherwise the chain will be waiting for grandpa votes that will just never arrive. So this grandpa node stalled tells the chain that it should be expecting a new validator set. And there are more extreme recovery methods possible, but not encouraged. I won't go into those here. As far as operational preventative measures, I think this is, at least like in my line of duty, one of the most important things, because you can screw things up with a bad deploy or a piece of hardware malfunctions, or there's any number of things that can go wrong when you're deploying things on real computers. And this is hopefully some ways that you can at least prevent some of these issues from happening in the first place. Make sure you have infrastructure as code. All of your nodes should be 100% reproducibly deployed. Like if you're using Kubernetes, if you're using bare metal, if you're using VMs, Terraform, whatever, all of this stuff, you should have everything in place. So if a node goes down, if it vanishes out of thin air, then you can bring it back up if needed. libp2p addresses rely on static ports and IPs, so you should make sure that you are using static IPs, and you're always specifying the ports with flags so they don't change. Otherwise, you can see some networking issues. Make sure you have health checks in place during rollouts. And if you're running VMs in a cloud, enable deletion prevention. This is like a small thing and it's not even blockchain related. It's just like if you're running critical nodes, you should have deletion prevention enabled, because then if somebody fat fingers a deploy, then it will prevent you from accidentally deleting things. And rollouts of like new binaries or new chain specs or whatever, any type of rollout should be slow or staged, like done in stages. So, try something on one node first, make sure everything looks good, and then maybe do 10, maybe do 20, depending on how big your network is. And then that will help prevent some of these issues. Your Keystore population should be automated. You shouldn't have to SSH into your node and run rotate keys directly on the host. You should have something in place for this that allows you to either remotely populate key stores and then get all of those keys back, or have something in place in your deployment which already installs these keys for you. And I can't say this enough, monitor everything from the substrate process. The Prometheus exporter built in is incredible. You should use it. Monitor the nodes that you're running, monitor the health status of the clouds you're using, all of this stuff. And because the sooner that you can detect a problem, the sooner that you can either mitigate it by spinning up new nodes or taking any other action that you need to take. Aggregate logs, especially in testnets and development. This is very useful for debugging. So you just have like logs all in one place, and then you can potentially alert on logs as well. So if you have error logs, or if your binary is panicking, or anything like that, then you will immediately have visibility into the fact that something is going wrong. And that create alerts for your infrastructure. That's basic thing. And you can follow DevOps best practices. I've written gist here quite a while back, and this is kind of another just a quick checklist overview of general DevOps best practices to follow for Substrate. So last ditch recovery. So you're sitting there, it's midnight, your chain isn't producing blocks, or your chain isn't finalizing, or you pushed a runtime upgrade, you uploaded the wrong verification code, something went very wrong. What do you do? Exhaust all other options first. Go through everything from this presentation before you start panicking, and see if there's anything else that can be done, if your chain is well and truly bricked or not. Reasons that it could be, almost unrecoverable. It could be, failed runtime upgrade or migration. If you're not producing any blocks at all, because then you can't really get any changes in, or the chain has been stalled for too many epochs. If you still have access to the runtime and can send transactions, there may be a way to recover. This is beyond my skill set, so don't ask me any questions about it. But there are ways to do this. Or you can fork the chain and migrate the state. This is like the last ditch effort, and generally you don't want to do that, if at all possible. All right. Any questions? That's about it.
Awesome talk. Thank you, Erin. It was really good, very insightful. You mentioned that there's you need to automate all the code, all the infrastructure development, deployment. So does this mean that, for example, you would prefer to put Kubernetes and then Docker? If we do this against, compare with using virtual machines, is there any just benefits of deploying on virtual machine or deploying on containers?
Yeah, so this is a question that I've seen from the community a few times. And really, it's kind of what you're most comfortable with and what providers that you're already using, like budget comes into account. Like some clouds are more expensive than others. Bare metal machines and deploying Docker images on them might be cheaper. So there's really so many ways that you can do infrastructure. There's not really like a one size fits all thing. But there are, I think, like in my day-to-day practice, we run nodes in Kubernetes, we run nodes on VMs, and we also run nodes on just bare metal machines. So it's really kind of like what best fits for the skill set of your engineers, and also what best fits the application. So for example, you want a test net, you can auto scale up like to tons and tons of nodes. Maybe Kubernetes is best for that. If you want to run like a node that has like 400 peers and like is constantly sending and receiving tons of traffic, maybe you want to put it on a VM or on a bare metal machine. It's really kind of like up to you. There's no best answer.
Okay, thank you. Yeah, that's a really good answer. So we have a question here from the public. So it's in a scenario where I have a automated 4G failover. If the 4G is enabled and I'm able to restart the node with a new static IP, is that okay?
It is okay. Like it probably will be okay. You might see some like spurious disconnects because the DHT is expecting a different multi-address for your node from your old IP. So it might take a while for that to propagate through the DHT. So it might cause some connection issues at first. But if there's nothing that you can do about it, then yeah. But if this is like running a node in like a production scenario, you really should figure out a way to have a static IP or at least a DNS address instead or something.
Okay, great. Thanks for that. Yeah, I have another question. It's like we usually deploy on huge machines, like really, like we use a lot of big servers. So is there any like requirement or any like, I mean, like any suggestion from your side, like how we can measure the size of the virtual machines that we should be using?
If you're talking about kind of like resource requirements, I mean, that kind of depends on your node that you're running and what chain you're running on, and like what type of node you're running as well. So like, for example, if you're hosting like a public RPC node, like that might require a lot more CPU than if you're just running a regular full node. So it really depends on like the transaction throughput of the network, like all sorts of things. You kind of would have to kind of benchmark yourself to maybe get a feel for the resource requirements. Generally, it's better to over provision than under provision. But if you're really trying to like get away with squeezing as many nodes as you can on one big machine, yeah, I think that would just be a case of benchmarking and getting an idea of how many resources each process takes up based on the workload that you're giving it.
Okay, thank you so much.